Welcome to How Many DataFrame Libraries Do You Need to Change a Light Bulb by Dharhas Pothina. Let's give him a round of warm applause.
Thank you. Okay, folks, my name's Dharhas Pothina. I work at Quansight, which is a consulting firm focused on open source and numerical computing. This talk is written by one of my colleagues, Marco Gorelli, who's a pandas and polars maintainer. He's in the UK, so he's not here, so I'm going to do the talk. I'll start off with, I spent way too much time yesterday trying to use GenAI to make an image, and I found out that GenAI has issues with light bulb orientation and step ladders. And so as you can see, this took a long time, maybe longer than the talk, but the light bulb is still the wrong way. This is the best one I got. Anyway, I had to do Python stuff and data stuff before pandas existed, okay? Who here has ever used NumPy structured arrays? Okay. Or NumPy arrays in dictionaries doing weird stuff. Yes, much faster and really annoying when you're dealing with missing data and everything else like that. So, I started using Python. I moved from MATLAB to Python in 2008, and I remember at SciPy about 15 years ago, there was a birds of a feather session where everyone got in the room and discussed how are we going to do labeled arrays. And all the problems with labeled arrays and aligning rows, and there was this big discussion about all the problems and things we shouldn't do when we build labeled arrays. Fast forward a year, Wes McKinney comes back. He was in that room, the first meeting. Comes back a year later and says, "Hey, here's pandas. By the way, I ignored a bunch of stuff everyone said about things we shouldn't do." A working implementation is always better than a theoretical best case, and so pandas took over the world. And over the years, there have been many attempts to displace pandas. Right now, a list of relevant DataFrame libraries. There's also probably another 10 that I haven't mentioned here that tried some stuff and sort of disappeared. So I'm trying to give an overview for folks who are trying to think about doing something different. And we're going to mostly focus on pandas, polars, and DuckDB, and also on a single computer, single node, like what you can do on your laptop, not kind of clusters and really big data sets. I'm going to talk about pandas and why, where we came from. Then I'm going to kind of compare with polars, compare with DuckDB, and kind of think a little bit about the road ahead. There is no harm in using pandas. Pandas is a very mature library. It's been around forever, as you all know. It has a lot of use cases, and it has a lot of domain-specific libraries built on top of it, using GeoPandas, which is a tool built on top of pandas. It is extremely widely used. If you take any data science library, it is going to have support for pandas. It's going to have plotting support. It's going to have machine learning support. Everything you need to use is there. It is very flexible. You can do a lot of stuff with it. And, it pretty much has all the data types you need. It has sparse, complex numbers, all sorts of stuff. Why you might not want to use it. One of the biggest reasons people don't want to use it is performance. And I'm going to go a little bit into this. But I'm also going to look. This table you see talks about a group by of 50 gigabytes. And I kind of want to take people, think about that a second. The idea that you'd be managing 50 gigabytes of data on a single laptop is new. 10, 15 years ago, a couple of gigabytes was considered big data when you were considering a single laptop. So now things have shifted. Pandas was built as an eager library, and I'm going to talk a little bit in a minute about what we mean by eager. And because it's eager, it doesn't do what we're going to call query optimization. It uses a lot of memory, which limits where you can use it. Typically, and I haven't used pandas recently, the pandas also has had a lot of optimizations, but the last time I was using it in anger, once you hit a 3 gigabyte Parquet file, you started having issues with your laptop and memory and stuff. There are also tools to help with this. You can use Modin or Dask, which use pandas under the hood and then parallelize it across threads. But I'm not going to go into that, or like if you're doing a cluster with Dask. But if you look at this table, pandas just fails on a 50 gigabyte data set on a single machine. But DuckDB and polars, you're doing this join in 2 minutes, which previously you'd need a cluster for. So the performance is one of the key reasons why you try some of these new tools. Who has actually used reset index equals true? Okay? Who knows why you do that? Exactly. I had a colleague, Tony Fast, who's a Jupyter core contributor. He was a pandas ninja. He could write stuff with pandas that did amazing stuff, and I'd look at his code and I'd see reset index drop equals true and all this. I'm like, I have no idea what it's doing. It's amazing, but I have no idea what it's doing. Pandas has a very strong API that can do lots of things, but it also has an index. And the index allows for a lot of stuff. Like, it allows you to have multi-indexes, categorical, like hierarchical tables, but it also makes it very complicated to understand what's doing. Has anyone hit the whole your row might be copied warning? Yeah. So it's very powerful, but it takes some time to really understand what's going on. Polars and DuckDB don't use indexes. And that has its own complications, but it actually simplifies the API a lot. Okay, I'm gonna shift a little. Pandas great, Pandas awesome. Now let's talk about polars. Okay, what's the same? It's Python based. Pandas and polars are both Python APIs. Primarily single node. You know, you use pandas or polars on a single laptop or a single workstation. They both have a defined row order. So the order the rows are in your data frame are fixed. You know, the row order is known. It's not like random. And they both support eager execution. And you know, you can use both of them with CUDA, or with CUDA for GPU back stuff via rapids. But the eager execution is what is going to cause pandas to not do well at scale. What eager execution means, as soon as you ask pandas to do something, it does it. If you ask it to read a CSV or read a Parquet file, it immediately reads it. If you ask it to take an average on a column, it immediately takes the average. If you ask it to do a sum, it immediately takes the sum. Polars is both eager and lazy. The reason that matters is because polars is lazy, it does not compute things until you say, actually, now go ahead and compute. What this allows it to do is look at all the operations you have asked and then optimize them. So if I have a large Parquet file with 100 columns, I say read Parquet, and then I say calculate the average of total cost, which is one of the columns. Pandas is going to read all 100 columns, all the data, and then it's going to calculate the average of that one column. Whereas polars is going to look at those two requests and say, oh, I actually only need to read one column. And I only need to calculate the average on that one column. So it has the ability to basically look at the whole list of operations and just work out which ones you actually need to do, reorder them if necessary, see if there are common things that several operations are doing, minimize the work that needs to be done. Also, by default, it's multi-threaded. By default, Pandas is single core. You can use something like Dask or other tools to parallelize it, and some operations in Pandas are parallelized under the hood, but in general, it's single core. And Polars has done a lot of work on memory optimization. Also should mention it's written in Rust, which gives it some other advantages in speed. But, as we said earlier, you can do a 50 gigabyte query in 2 minutes versus not being able to do it in Pandas. So, big reason to go. Here's the interesting thing. What we've seen is, and there's a couple of talks by Marco Gorelli about this, people seem to move to Pandas because of performance. Like, oh wow, I can do a 50 gigabyte data set. The reason you stay there is the syntax. Someone who's used Pandas for a very long time, 15 years since it was around, and I've only recently been playing around with Polars. And I don't do, I'm higher up in the organization now, so I don't get to do as much hands-on coding as other people, but I really fell in love with the expression system. It takes a little while to get your head around it, but It is very composable and very generalizable, and it's really easy to build up complex expressions or collections of expressions without having to keep Googling Stack Overflow about how to do some arcane thing with Pandas API. But again, there's a lot more information about how to do arcane things with Pandas API on Stack Overflow, so, mileage may vary a little. Data types. Pandas has lots of confusing data types. But here I want to say we're not dissing Pandas here. Polars and other tools have had the experience of being able to look in the rearview mirror and see what was done and say, oh, if we started fresh today, how would we do it? Polars has much simpler data types. Guess why? Because it's using Arrow under the hood for its data types. Guess what didn't exist when Pandas was written? Arrow. So, yes, Pandas has 3 types of integers, 64s, 5 types of nans, but that's also the fact that it was built 15 years ago when Arrow and other tooling did not exist. And now, if you use Pandas with the Arrow backend, it is actually pretty good. But also, it supports some complex data types that Polars doesn't. If you want to do complex, numbers, sparse, period, there's some other stuff. But anyway, if you want to do some of these complex data types, Pandas is where they're at. They're not in Polars yet. I mean, they probably will be eventually, but right now, so again, D types. Verdict, are you starting a new project? No? Is your project broken? No? No reason to move. Your stuff works, it's good, you haven't hit any of the limits of Pandas. Pandas is not a bad tool. We are not hating on Pandas here. There's just better tools for certain things. Also, if you're using an upstream domain library like GeoPandas or something, you can't use GeoPandas with Polars. Just can't. Do you need things like geospatial data, complex numbers, sparse data? Stay with Pandas. If you don't, try Polars, or as we'll see, you could also try DuckDB, because DuckDB has some geospatial stuff. A good way to do this is if you're doing a new thing, try a new tool. The way I got into Polars is I need to do some analysis of our company financials and salaries and stuff, getting ready for a compensation review, and I was like, okay, I'm going to pull all the numbers into Polars and learn Polars expressions along the way. Switching gears a bit, DuckDB. Okay, who's heard of DuckDB? Okay. And I'm not going to really compare it with Pandas, I'm going to compare it with Polars instead. Again, single node, supports lazy execution. Again, as I said, with lazy execution, you define what you want to do, you chain it all together, and then you let an optimizer decide how best to arrange those tasks before doing it. We can work with larger than memory data sets. This is the actual thing. Actually, should have mentioned this with Polars as well, is both of these work with out-of-memory data sets. If you have a 50 gigabyte data set, and if you consider a 50 gigabyte Parquet file, when you decompress it, it's probably like 150, 200 gigabytes, of RAM. I have the original M1 Mac Pro, which Apple skimps out on memory, so it only has 16 gigabytes of memory. And so there's no way I'm going to load that into memory. And so Polars and DuckDB, what they're doing is they're streaming the data through memory. You're not loading all 50 gigabytes. You're kind of, actually other tools like Dask do this as well. But you're not actually loading everything in memory and then computing on it, which is what Pandas does. So, it works with larger memory data sets. So even if you have a really large data set, it will chug through it. Even if you have low memory on your laptop, it'll take longer, but it'll chug through it and it won't just die. The other thing that DuckDB, I'm not going to go into detail about this, but it's an in-process OLAP system. And so for folks who use SQLite, SQLite is a single file database that a lot of tools use when they need a data store on disk. And that's another in-process database. But it's a traditional transactional database. Transactional databases are designed for transactions, and typically row transactions. When you're entering a new record for an employee, or deleting a payroll record. It's one row at a time. Most of our data science analytical workloads are the other way. They're column. We want to do things in columns. Taking a traditional transactional database and doing something via column is painful, which is why we usually pull the data out, then use something like Dask or pandas or polars to process it. DuckDB kind of turned that on its head and said, okay, let's build a database system that works for analytics, and that's what they did. Again, data types, it's more standard. They have most of the common data types. The other interesting thing that they support that Polars doesn't support is a float 16, which in some cases is useful. They have a really good decimal data type. Pandas also has a decimal data type. Polars, on the other hand, has enum and categorical data types that DuckDB doesn't, but the decimal data type is still sort of experimental at this point. So again, depending on which data type you care about, that might or might not matter. Syntax. Who likes SQL? I thought so. This is the conference where people won't like SQL. I've been to some conferences and they're like, dude, SQL, man, why can't we write SQL? And every time I've used, Pandas has a read SQL and Dask has read SQL, and every time I have to use them, I'm not happy. I can write SQL, but I find it not a very expressive language. But if you like SQL, DuckDB's got you. It essentially, you write SQL, and it does awesome fast stuff. And, I don't know why this is, but Marco says they have an innovation in SQL called group by all, and it's amazing, and there's nothing else out there like it. I don't know enough about SQL to know why that matters, but supposedly it's awesome. It's limited in its Python API. DuckDB, if you like Python and you writing your analytics in Python, maybe not DuckDB. Well, actually, I'll get into that later. This is an interesting thing. Row order is undefined because it's a database system. When you ask for stuff, the order in which you get your rows is not defined or is undefined. So if you're doing things like accumulative sum depends on the order. So you have to put a second piece in there, like order by, order by date or order by this column, along with the cumulative sum, because there's no guarantee on the row order you get back. And extensibility. Pandas is reasonably extensible. It's got this concept called extension arrays, and people have used it. GeoPandas uses extension arrays. CyberPandas uses extension arrays. In Polars and DuckDB, the way you do extensions, one thing is DuckDB, you can write subqueries or common table expressions in your system, but if you want to extend it, you write C++ plugins. If you want to write Polars extensions, you write Rust plugins. This is actually a key interesting piece of Polars, is how well they've built their plugin system and how well that plugin system integrates with their expression engine. And that's why Marco has some good examples of time series functionality and business date logic that are implemented as a Rust plugin that is not part of Polars core, but can be used very seamlessly. And we've used that with several clients. We did some work with a client to do geospatial location mapping, like address lookups, and we rewrote that as a Rust plugin that can be just used. It is blazing fast. And so the extensibility of both Polars, and also, Rust is a big thing now. So if you say you use Rust, you automatically get, 5 extra bonus points in most conference talks and everything else, versus saying, oh, write a C++ thing. So, or Python or something. Performance-wise, it's a little bit different. At larger scales, DuckDB wins. It has a better streaming engine for really large scales. And for this, I think a little bit later I have a link to a blog post by Coiled where they looked at Dask, Spark, Polars, and DuckDB from 1 terabyte to 10 terabytes. And that's actually a fairly well-built benchmark on the TPCH things. And you can kind of see where all these tools do well. Again, I always like to say it's not big data, it's data of unusual size, in the sense that any data you can't comfortably handle is big data for you. And there's not many people who typically do 10 terabytes of data at a time. But 50 to 500 gigabytes, I think we all hit those data sets much more commonly. And in the smaller 50 to 100, they're probably both fine. Again, DuckDB, it's not got row ordering. So certain things like windowed operations and stuff are a little more harder because if you're doing a windowed operation, you need the ordering. And so it doesn't do quite as well. Polars has very fast window operations. You can also do things like sort your data once. Polars remembers it's sorted. And so you've got lots of little tricks in this. DuckDB is only lazy. Okay? And only lazy is fine. But usually when you're experimenting and trying to get your algorithm worked out, you need eager. You need to see what the shape of the data is, what it's looking like, before you turn on lazy. And so DuckDB not having an eager object makes it a little, to some extent what you do is you do all your DuckDB stuff, serialize it to polars or pandas, and then do your normal work there. So you kind of have, I would say for this audience, if you use DuckDB, it's one step of a larger workflow that then switches to pandas or polars. Whereas polars, you kind of can flip back between eager, lazy, and I think they have a streaming, kind of 3 different APIs. My personal opinion is, do you like SQL? Okay? If you like SQL, this gives you a really good way of writing queries. If you want the larger data sets, you might want to use this over polars. It also, again, DuckDB has a very good 2 polars, 2 pandas type thing. So you can kind of start doing things in DuckDB and then move over to pandas and polars and kind of continue from there. The one thing I will say is, who has heard of LLMs? Some of you. If you are using an LLM, or if you're using you're trying to build any kind of thing that's using agents or automating workflows or something, use SQL. We try to do several experiments of using LLMs to write pandas code or polars code. The pandas and polars syntax and API change so often. There's so many different questions on Stack Overflow from pandas 0.13 to pandas 2 with different APIs. You've got uppercase, lowercase. Getting an LLM to give you runnable code with pandas or polars or pretty much any Python library is very iffy. Asking an LLM to write SQL, it's a defined grammar. It hasn't changed in forever. So getting an LLM to write SQL is easy. So I know of several folks who are trying to build automation tools on top of LLMs, and they're using DuckDB as the backend because you have the speed, the high performance, all that kind of stuff. And, the LLM is really good at writing SQL. And so if you want to do LLM automation, that's the way to go. Again, it's dropped down a bit, but learn all of these. Learn both. I'm assuming you guys already know pandas or pretend to know pandas. But, learn both polars and DuckDB. They're tools which have places where they fit in very well. Again, I personally find it very difficult to express things in SQL. Once you have 2 or 3 select and inserts and joins and group bys, it looks like a word salad to me. DuckDB wants you to live in SQL. If you want to live in SQL, stay there. If you want to use DuckDB at the top to do some fast SQL queries and then move to something else, I would do that. I don't find SQL particularly readable, so I have a bias against it. But I'm also at the PyData conference right now. If I went to certain other conferences, I'm pretty sure everyone would tell me that polars and pandas and the rest of the Python ecosystem is nuts considering the way we build APIs. So, again, a good time to try this, experiment on a new project. This is my best thing. If you have a small project that you need to do, a small analysis, pick one of these tools. Pick polars, pick DuckDB, try it out, try it out for yourself, see where things break, see where things, do well. I'm going to roll back a second and look at syntax again just to kind of make it a little more visual. This is pandas. Read CSV, group by, make, transform, usual stuff, okay? This is what it would look like in polars. You use, and again, there's a longer talk about how expressions work, but you basically build up a list of expressions and then, polars will handle it. And if you look here you have the index. 258 is an index. Here we don't have an index. You will need to learn a new syntax. There are a lot of, pontificating a little bit, there are a lot of tools that were built, DataFrame tools that were built in the last 15 years that basically did not attempt to change pandas syntax. They basically said, hey, our new tool is faster than pandas, and we're going to copy pandas syntax so life is easy. And you can get pretty far with them. Modin's a drop-in replacement. Dask DataFrame is a very close replacement, almost exactly. You can take from import pandas PD to import Dask DataFrame as DD, and most things work. And there's a couple of things, but Polars, DuckDB is SQL, so it's different. But Polars, what they did is they built their own syntax the way they felt it should be built, to be expressive, to be optimized for doing lazy execution and optimizing queries. And they focused heavily on performance and memory usage. And so it's a very well-built tool. It does require you to learn a new syntax. But my experience personally, as someone who's not an expert on Polars, I don't develop Polars, and just used it recently, once you get an understanding of how it works, it's actually a lot easier to build on than I think Pandas is. Again, DuckDB, SQL. I've said enough about SQL. So if you like SQL, select, from, group, all that kind of join stuff. And again, as you see, there's no index. Like similar to Polars, there's no index in the output. I mentioned this before. My opinion is there are some analytical workflows that aren't really easy to express in SQL. And while DuckDB has a Python API, it doesn't always work, and it's not very documented, and it doesn't really fit a Python brain. So I would use DuckDB at the top of Notebook, get your data, and then switch to Pandas, Polars later. I would not do an entire workflow purely in DuckDB. Okay, the road ahead. Again, I don't think there's these tools are bringing different things to the table, and they're all valuable. Pandas has the stability and the static API. I know a lot of the Pandas maintainers, they're very careful about not breaking backward compatibility. They are very careful about, there's this big debate right now about whether PyArrow should be included as a core dependency or not, because if they include it as a core dependency, it increases the download size, which in certain situations makes it difficult to use Pandas on certain types of machines. And so they are very careful about moving carefully. But it's not an either or. If you use the Arrow backend in Pandas, you can often do a zero copy switch. You can do part of your workflow in Pandas, switch to Polars, part of your workflow in Polars, switch, because you now have this zero copy switch with PyArrow. And again, you can query Pandas, data frames, and Polars from DuckDB if you like SQL. And DuckDB can push to all of these. So if you're starting a new project, play around with DuckDB and Polars. But there's space for all three. I've already said this. Pandas is the most common tool. Polars is increasing. One of the big disses I gave to Polars is upstream compatibility, downstream compatibility with other libraries. But that's improving. Like Scikit has a lot of algorithms that can use Polars data frames directly right now. A lot of work that's been done in the DataFrame API collaboration that we helped build some interfaces so data frames can work better together. I'm going to only have a few minutes. I'm going to quickly mention another tool, Narwhals, which is developed by Marco. And this is for library maintainers. And so this is more like a push. If you are developing a DataFrame library or any kind of library that wants to support Pandas, Polars, DuckDB, other things seamlessly under the hood without having to say, oh, you have to have Pandas, use Narwhals. It's a lightweight, stable, dependency-free, pure Python library that lets you support multiple DataFrame libraries. And for example, the reason Altair can use Polars is because it's using Narwhals under the hood. And this is not an end-user tool. This is not for, if you want an end-user tool that can hit multiple databases and stuff, Ibis folks. That's That's what Ibis is for. This is more of a tool for library maintainers to support multiple DataFrame libraries. And so right now, you can pass pandas, polars, PyArrow, Dask, Modin, and QDF into your library via Narwhals, and it handles all the compatibility stuff for you. Zero dependencies, no data conversion. It does 0 memory copies. With that, conclusions. Pandas is awesome. Pandas is everywhere. This is not a hate on pandas. But having new tools in the ecosystem makes the ecosystem better. And DuckDB and polars will require an investment in learning new syntax, but they give you more choices, and especially, I think it's a game changer. I talked to a lot of people in enterprise. They read a file in pandas, it crashes their computer, it crashes their kernel. They're like, okay, fine, I can't do this. That's changed. This is 10x, 100x larger data sets that you can do on your own laptop without having to talk to IT about giving you a cluster. And this is not even talking about using the CUDA versions of polars or anything like that. This is just simple CPU-based stuff. And earlier this summer, polars kind of announced their CUDA integration, and I haven't personally tried that out again, but I'm pretty excited about it. And if you are a tool builder that wants to support multiple libraries, use Narwhals or contact us, and I'll get you in touch with Marco.
Thank you.